In this video, we will see the procedure for removing duplicate elements from a sorted linked list. Here is an example of sorted linked list. The elements are 3, 5, 5, 8, 8, 8. So there are duplicate elements. If you take only distinct elements that are 3, 5 and 8, so we want to remove duplicates. What should be the procedure for removing duplicates? So let me show you the procedure. For removing duplicates, we need two pointers. Let us take one pointer P upon first node, and also on the next node, we should have one pointer Q. The idea is we have to check whether the current node and the next node data is same. If data is same, we can delete any one of the nodes. So let us delete the second node. So for that, we need two pointers. So I have first pointer upon first node and the pointer Q upon next node. Now let us see the procedure. The procedure is check whether the data in P's node and the Q node, is it matching? It's not matching. If the data is not matching, that is Q3 and 5, they are not matching, then move P upon Q and move Q to next node. If they're not matching, then slide them. Now let us see next. P's data and Q's data, it's matching. If the data is matching, then what we should do? We have to delete the node. So which one? We will delete the second node. Actually, we can delete any node, but here we are deleting second node. So how to delete this node? Make P's next point on Q's next. This is the first step. Then delete this node at Q. Okay, delete the node. Then make a Q point on this node. That is P's next. So these are the three steps. Make this P point on next node of Q, delete Q, then move Q to P's next. So till here, let me write down some procedure, the code, then I will continue rest of the nodes. See, we need a pointer P upon first node, then we need a pointer Q on next node of first node. Q is pointing on second node, that is next of first. We have already seen this, initial. Then what we have to do? Compare the data of P and Q, if they are equal or not equal. So if they are not equal, then we will slide the pointers. So let us write on that code. If P cap's data, if P cap data is not equal to Q cap data, then move P upon Q and move Q to next node. So they will be sliding like this. This is over. Sure. If the data is equal, then what are the steps we have done? In else part, I will write down. P's next should be Q's next. So remember Q was here, right? So P's next here, it should be Q's next. So P's next is Q's next. Then delete this node where Q is pointing. Delete Q, this node will be deleted. Then move Q to next node of P. So Q will be pointing on next node of P. So Q will be pointing here. So I have written the program code up to what all we have learned. Now let us continue, and this time we will be tracing the code. We'll be tracing the code. Now P is here and Q is here. Check the data, 5 and 8, they are not equal. So P should point on Q and Q should point on next node. They have slided if part was executed. Once again repeat. Is the data matching? 8, 8, they are not equal? No, they are equal, it's matching. Enter into else part. So what we should do in else part? P's next should be Q's next. P's next should be Q's next. So this one. Then delete node Q. Node Q is deleted. Then make a Q point on P's next. Q should point on P's next. So when they were matching, we did this one. Continue. Data not equal. 8, 8, not equal. No, it is equal. Enter into else part. Okay. P's next should be Q's next. P's next should be Q's next. What is Q's next? Null. So make it null. Make it null. Then delete Q. This node is deleted. Next, Q is equals to P's next. So Q should become P's next. What is P's next? Null. So Q became null. So Q has reached the end of the linked list. So there are no nodes further. So we should stop. We should stop. So this repeatedly we have done, and we have stopped when the Q became null. So this should be repeated in a loop while Q is not equal to null. So our condition is Q is not equal to null. So this is the procedure for removing duplicates from a linked list. Little bit of analysis. How many pointers required extra pointers? P and Q. Can we do it with less number of pointers, that is just one pointer? Check it whether it is possible or not. You find out. Then what is the time taken by this one? It is scanning through entire linked list, that is traversing a linked list. It's order of n, and it must traverse the entire linked list. So it's always order of n. So there is no minimum maximum. So time is order of n.